Hi, everybody. Y'all excited about talking about software architecture? Oh, wow, that works better, way better than I thought. I thought it was like the saddest hype statement ever. I'm going to talk about software architecture. I don't know if there's any intro stuff I need to say. No, let's get going. So, my name is Bob Nystrom. When I was a teenager, my brother and I spent a lot of time working on a tabletop role-playing game, and at some point I found myself starting to hack on my own roguelike, and I've been kind of tinkering on it ever since. That was 20 years ago. It's nowhere close to being done, so I have poor resource management skills, apparently. During that time, I worked for EA for 8 years, so I have experience being trapped in dungeons for a long time. As part of my escape plan, I wrote this book on software architecture called Game Programming Patterns. It's a real book, but you can also read the entire thing online on the web at that kind of hard to read URL right there. Right now I'm in the middle of writing another book on programming languages. You can't read the entire thing online because it's not done, but the stuff that is done you can read online. But the accomplishment that I'm most proud of in life, above and beyond even having children, is that I beat Angband. Never been in front of an audience that would appreciate that. This is a high elf mage. This is around 2.9.3. Very proud of myself. Okay, so this talk is, there's bullet points. Oh, I should point out that I wrote a custom program for my presentation using the same engine as my game because I wanted to just go full nerd. So I'm going to talk a little bit about what the ECS pattern is, or at least sort of my understanding of the classical conception of it. I'm going to talk about why I don't use it in my roguelike, and stuff architectural patterns that I do use instead that I think are super cool. So let's talk about let's talk about ECS. Stands for Entity Component System, if you don't know. Some of those are pluralized, but I'm never sure which ones are supposed to be plural, so I didn't pluralize any of them. So we'll start with entities. So imagine you're, back in the day, maybe not back in the day, writing a AAA game, and you are implementing, a character in the game, right? So the entity is the class that represents that character. You might call it entity, you might call it game object, something like that. And in a sort of modern, real-time interactive game, there's a lot of stuff in there across a lot of domains, right? So like, you've got AI doing like pathfinding and like playing scripted events. There's like physics interacting with the world. There's this whole animation system that's driving your skeletal animation, and then there's a rendering layer on top of that. And all of these domains interact with each other, right? So like the IK for foot planting in your animation needs to take into account the surrounding physics volumes, and it's this big ball of stuff, right? So you can imagine just jamming it all in one class, which is what they did in the 90s. And if you talk to old game developers, you'll hear horror stories of like a game object class that was like 20,000 lines of code. So that's bad. So problem number one is complexity, right? So you have this one entity class that touches a lot of domains, and sort of everything is jammed together. So the solution they came up with is components. So basically what you do is you look at that entity class and you take each domain, sort of, you can imagine each specialization in game development, and you pull the data and the code for that out into a separate class. So you have an AI component, a physics component, animation, graphics, maybe some sound, maybe other stuff. And then your entity class becomes basically just a bag of components, right? So it gets a lot smaller, a lot simpler, and each domain is encapsulated in separate code, which is nice because a lot of times these are maintained by different people too. So the next thing it does is, okay, so this is a game loop, right? So you're running through your entities and you're updating them, and you tell each entity to update. Entity does the stuff it's supposed to do, except this is not a correct game loop. The way your game loop is supposed to work is that each domain runs in a separate phase. You do all the AI for every actor, then you do all the animation, then all the physics. So let's see, what is my next slide here? So the bad thing about this is if you do it this way, where all of your entities are jammed into the same class, all the domains are jammed into the same class, it's slow. So there's this performance problem. So how many of you know anything about CPU caching? So if I ask you like about cache misses and stuff, Okay, so a couple of you, which is good. So you know about Moore's law, right? So CPUs have been getting twice as fast every 18 months, which is like awesome as we software users, because it means we get to be twice as lazy every 18 months as developers. Unfortunately, RAM didn't keep up, right? So RAM has not gotten faster like that, and it turns out having a super fast CPU is not very useful if you can't actually get data onto it fast enough. So what CPUs do is they have caching on the chip, and when you read from RAM, they speculatively pull in nearby memory onto the cache, and that way it can be accessed faster. And that's based on the assumption that if you access byte here, the next thing you're going to need is the byte next to it, right? So if you access them that way, it's super fast, and if it's not, it's way slower. And by way slower, I mean like 2 orders of magnitude slower. So the difference between like a 60 frame per second game and like a 1 frame per second game. So let's see if when you have a monolithic entity class with all of the state for each domain, mixed together, then you have an array of those in memory. As you're skipping through updating the animation stuff, you're skipping over the physics and the other domains, and you're just blowing your cache every time, right? So it's super slow. When you pull this stuff out into components, that means you can make these homogeneous arrays of each component. So when you're updating the physics, you're just like stepping through memory and not skipping over anything. So this makes a big difference for perf. This is like if you were like a modern sort of AAA real-time game developer, like this stuff is your life, for better or worse. So the systems part of this is like a little bit vague, but basically if you imagine the code that is sort of stepping through that domain, that's kind of what a system is, and some people pull that out of the component, and some people don't. Sorry, this is an example of a system here. So you can see it's just walking through AI components, and the useful thing is that it is not mentioning the entity at all, right? It just goes straight to the components. It's not skipping around in memory, and that's what's kind of making your CPU happy. Okay, so how does this apply to the world's best game genre? So problem number 1, complexity. So let's think about, take your monster class in your roguelike and think about the domains. The physics is not super complicated. Graphics, fidelity is maybe not, that's more or less equivalent to the complexity of like, bone skin mesh animation, right? The AI is interesting though, right? Like there is actually quite a bit of stuff in AI, right? Like monsters can do lots of different stuff. There's pathfinding. These things interact with each other. So maybe, you have a monster that's afraid and it has a teleport special move, doesn't know to use teleport to get away, stuff like that. So this domain is kind of interesting. I went ahead too far. So if you imagine taking your entity class in your roguelike and splitting it along domains, you get this super lopsided thing where your animation component and your physics component are useless, and then like the AI component is all the things, right? So it's not super helpful for kind of, breaking down your code and organizing it. And then we can talk about performance. So of those of you who know what CPU caching is, how many of you have performance problems in your roguelike? You. How many of you, oh wait, sorry, was there another one? I see 3. 3 of you. How many of you know that it's because of CPU cache misses? This is still 3, okay. So the rest of you, this pattern is not helpful for you, right? So, which is kind of weird because you see a lot of people online saying like, I'm working on my roguelike and I want to use ECS, and it's like, okay, well, do you have these problems? I sort of think of it as like going into the doctor and being like, yeah, I hear really good things about C-sections. Can I have one? And it's like, are you pregnant? No. So at least in the classic incarnation of like splitting along domain boundaries, I don't think it's a super good fit. But that does not mean that roguelikes do not have problems, at least organizationally. So how many of you actually are working on your own roguelike right now? Okay, lots of hands. It'd be weird if like none of you raised your hands, because why would you be listening to me talk about this? It'd be strange. So how many of you feel like you struggle with software architecture issues, organizational issues, yeah, I do. I run into stuff like this all the time where it's like I know what I want the code to do, but I have trouble figuring out how to organize it, right? So I'll go through a couple of problems that, that I run into a lot. So one thing, this is something I really like about roguelikes, is there's a lot of behavioral complexity, right? There's just a lot of different stuff that entities in the game can do. So this is my game right now, just the different things that like monsters and the hero can do, right? Like there's like item management, there's like all these like special effects. So you have a lot of behavioral richness. And then there's a wider breadth of content. So Fortnite, there's like two kinds of, I don't know anything about Fortnite, I don't know how this works, but like Fortnite has like 16 different kinds of monsters, and I think they're basically all different zombies, which is not like super much. But ADOM has, according to the wiki, like 317 something monsters. So like your typical roguelike just has like a lot more breadth of content, right? And that is an organizational challenge, right? So I'm going to go through a couple of patterns, and these are patterns that I think have worked well for kind of helping me tame these issues. Whether or not they will help you, I don't make any promises. Okay, so let's talk about items. Items are awesome. You know, a lot of roguelikes are very equipment-based. A lot of the capabilities of your players based on equipment. What that means is there's just a lot of stuff that items can do, right? So like weapons can be used for melee attacks or ranged attacks. Maybe you've got armors, maybe shields increase your ability to dodge. There's stuff you can consume, things that you can activate and reuse. Sometimes stuff has passive effects. There's like a lot of just stuff an item can do, right? And if you jam all of that in one class, it's not super awesome, right? So the classic solution was like, okay, we'll use inheritance because inheritance will solve all the problems. And you make subclasses for all the different kinds of items. You know where this is going, right? If this was a talk in like 1995, you guys would have been like, yeah, subclassing is awesome. But now we have learned. So the problem is like, eventually you end up in a situation where like, I want to have a sword that shoots a fireball, and it's like, okay, well, I don't want to deal with like multiple inheritance and stuff like that, and it falls apart, right? So that's bad. So instead, what I do is I split out each capability that an item has into a separate class and a separate field. So there's a capability for being able to do an attack. There's a capability for being able to provide defense. Then there's capabilities for being able to use it, and that's kind of polymorphic, right? So there is a base use class, and then there are these subclasses for each of the different ways you can use it. And this is a case where I think actually inheritance works really well, where you have a hierarchy that's not very deep, but it's really wide. And then the item itself is just a combination of these capabilities, right? And you can sort of freely mix and match. So you want to make a sword, that's just an item that happens to have a melee attack, right? You want to make a shield, that's, it turns out you can also have a melee attack because maybe you could shield bash with it, right? So it works nicely too if you want to be able to, define kinds of content in data files, right? Because then you can read these from data and then you're constructing kinds of items procedurally. So this is pretty nice. Whether or not you call it component is kind of an interesting question, but I think of this as using components to represent capabilities instead of domains, or a sort of more general way to say this is just the old principle of preferring composition over inheritance. I think this works pretty well. I use it in a couple of different places. So monsters have special moves, and those are basically capability objects too. Speaking of monsters, let's talk about monsters. Monsters are awesome. So imagine your hero's in the dungeon, right? He's hanging out, and he's surrounded by 20 goblins, and goblins have lots of interesting stuff about them, position, health, how close to death they are, things like that. But there's a lot of stuff that they have in common, right? Because they're all goblins. And if you kind of stuff all that into the monster class, it gets sort of, there's a lot of extra state, it's kind of messy. So the solution that I have is, this is not super rocket science. I know this is not like galaxy brain right here, is to define a separate class that represents a kind of monster, right? So there's one instance of this breed class for a goblin, and then every goblin just has a breed that points to that. This is an old pattern. It's called the type object pattern. You are probably using this already. You've probably reinvented it. But it is super useful. It's nice to think about. One of the things I think is kind of interesting about it is, so you're implementing your game probably in an object-oriented language, and then you are basically reinventing object orientation at the application level, right? So this breed class is a class that sort of represents a class, right? So breed itself is kind of a meta class, and each instance of breed is a class. And that gives you some interesting opportunities to pick object-oriented features and re-implement themselves if they're useful. Like, we could give breed a pointer to another breed that was its parent breed that it inherits from, and we could define our own inheritance semantics if that's something that's useful for us. So that's kind of cool. I use the same thing for types of tiles in the world, for types of items, special modifiers on items. So the basic idea is defining a class that represents a type where each instance of that class is a new kind of type. Which sounds a little weird and meta when I say it like that. Okay, so let's talk about actions, which are awesome. So I don't call them entities, I call them actors. This is kind of the main class hierarchy for living stuff in the dungeon. So there's a base actor class that has the things that heroes and monsters have in common, position, health, things like that. And then there's a subclass for hero and a subclass for monster, which is just the stuff that's, the hero is always a little bit special in the game. And that's kind of the extent of the hierarchy. And before, I talked about all the different stuff that entities in the game can do, right? There's like a lot of behavioral richness. There's like item management, there's special effects, walking around the dungeon, combat. That behavioral code needs to live somewhere, right? So if you stuff all of that in the main actor class, you're right back to the sort of the original 90s 10,000 lines of code game object class where it's just like the whole game is inside there, right? And you hate your life and no longer want to live. So that's bad. And there's kind of a related problem too. So, for those of you that have your own roguelikes, how many of you have a speed system or an energy system where different actors and monsters can move at different speeds? I can barely see. It's a decent number of you. So this doesn't really work for your game loop, right? You can't just be like, okay, let the hero do their thing and then like run through the monsters and then repeat, right? Because if the hero's slower, that means more monsters need to get processed. If the hero's faster, the hero may need to take more turns. So you need a way to be able to kind of interleave the way heroes and monsters are being processed by the game loop. So that doesn't work. My solution is the Gang of Four pattern is called the command pattern. I'm calling it action here. So it's the command pattern. And what that is it's basically an object that represents an operation. Back in the day, this was like maybe a revolutionary concept. Most of us today are used to programming languages that have first-class functions. So it's basically just a closure. It's just an object that represents a thing that you can invoke. In practice, you can use just a raw function for this too. In practice, it is kind of nice to define a class because you end up getting some other functionality and stuff in there. So in my game, this action class, and an action is you can think of it as a first class turn. It represents a single step in the game that an actor can perform. And the way that works then in the game loop is the game loop up here is doing kind of the energy speed stuff where it's giving actors some energy based on how fast they move, and when they cross a certain threshold, they're allowed to take a turn. And the way they take the turn is the game loop asks the actor just like, give me your action, and then the game loop performs the action. This is super simplified in my game because there's like animated effects and stuff. This performing the action is also this iterative process as you sort of percolate through the consequences of the action. So splitting things up like this does a couple of nice things for us. So, for example, here's the action class for taking a step. It's kind of simplified down, but there's a lot of stuff in here, right? Like you walk into a door, we want to open the door. If you walk into another monster, you try to hit it. The actual details of this don't matter. I'm not going to give you like a test on this code. That'd be weird. The important part is like it is a lot of code though, right? And now it's a lot of code that's not inside actor. So it pulls all that stuff out. And when you think about the scale of like the behavioral richness, so these are the action classes in my game right now. This is a lot of different stuff, right? It's a lot of code, and all this gets pulled out of actor. And actor basically becomes kind of just sort of a data structure and maybe a little bit of code to sort of maintain invariance, like, yeah, your health is not allowed to go negative. The really nice thing about this model is what I love about roguelikes is that you can do a lot of stuff. So it makes the world feel more real. And this model makes it easy for me to add new behaviors without feeling like the sort of quadratic complexity of the code base is getting worse, right? Because these things are fairly decoupled from each other. It's not like I'm pouring more code into a class that's getting bigger and bigger and uglier. So it makes it feel like I can kind of just scale up the fun of my game without increasing the cognitive load of me trying to maintain that code. And then the other thing it does for us is it gives us an abstraction layer. So one of the main differences between the hero and monsters is the hero is driven by the player, and monsters are not. So the hero is driven by user input. And the way this works is when we ask the hero, like, what turn do you want to do, it uses user input, and it produces an action. And then when we ask a monster what to do, it runs the AI, and the AI's job is also to just produce an action. So what's nice about that is if the monster AI and the player-driven code was sort of procedurally just driving behavior, then it gets harder to share behavior between those two things. They end up just sort of doing the things directly, and you'd end up with two implementations of here's how to take a step, here's how to open a door, here's how to do a melee hit. But actions give us a nice abstraction layer for that. So the AI's job is just to construct an action object and yield it, and then the rest of the game engine, the game loop just kind of drives that, and then we get to share all of the same behavioral code between AI-controlled and player-controlled characters. It makes it easy to share things like spell effects and stuff like that. So that makes me happy. So the way I generalize this is if you find yourself getting stuck in your code and it feels like there's a missing set of flexibility, one of the techniques that's always worked really well for me is take some verb that's in the program, something that's being done, and turn it into a noun, create an actual object that represents that, because that gives you a way to, it makes it first class. You can create it in one place, use it in another place, you can start giving additional properties to it. It seems to generally be a nice technique. And that's basically it. There was a lot of code. I apologize for the quantity of code, especially right before lunch. I realize that's a lot to take in. So the super science summary is I don't use the classic sort of split along domain boundaries ECS pattern, and I don't think it's generally a good fit for any roguelike that is not super graphically rich or physically rich, or if you're turn-based and tile-based, I don't think it's doing much for you. But I do like using components in the sense that you split them along capabilities. I think type objects, even though it's a really just dead simple pattern, is super useful. I use it all the time. And then the command pattern, which isn't as well known as a lot of the other design patterns that are out there, it's not something that you use all the time, but when I run into situations where I do need it, it's incredibly powerful. If you've ever tried to, I don't know if any of you have ever built like a level editor or something, if you need to implement undo in an editor, if you use the command pattern, it just works, right? So each command also supports the ability to undo itself, and then your undo system is just maintain a list of historical commands, and you rewind them, and it's great. If you don't use the command pattern and you try to implement undo, you basically just never want to be a software engineer again. Not that I'm trying to oversell it. And that's what I got. So this is actually the level generator for my game running live right now in the middle of a presentation, which is probably not the smartest idea I've ever had, but it looks kind of cool. Anyway, thank you. If you want to learn more about my books, I have a blog. That's kind of the main URL that gets to all the other stuff. I brought a couple of copies of my book that I've been schlepping around the Bay Area for the past couple of days, and I totally don't want to schlep them around anymore. So if you would like a free copy of the book, come up and say hi. We don't have to interact. I understand I'm introverted, you're introverted. We don't have to make eye contact. You can kind of just take one. It's okay. And thanks. Enjoy your lunch, I guess.